Hello everyone, welcome to today's webinar. Today we're still talking about fractions. Today we're going to go over addition and subtraction. Before we start with our webinar for today, I would like to introduce myself. My name is Miriam. I'm here with Penn since October 2015. I am certified to teach high school math in the state of Pennsylvania since 2010, and I also earned my master's degree last year in education. Today we're going to go over some objectives that the section on that unit goes over, adding fractions, different kind of fractions. We're going to go over like fractions, unlike fractions, like mixed numbers, unlike mixed numbers, how to find a common multiple or a common denominator. And hopefully by the end of this webinar, you have enough practice and also enough knowledge about this section of the unit that when you go back to the unit and read it, it makes more sense to you. If you're attending today or you have registered for the webinar but could not attend, you still will get the recording after the session, about 5-6 hours from the conclusion of the webinar. You're able also to ask your questions by typing your questions in the questions box. The raise your hand feature is not enabled in our webinar. Let's start with the easiest kind of questions that you may get when you add fractions. The easiest topic is that when you have two fractions have the same denominator. If you remember from the first webinar we did last week, and it's also available now on YouTube channel, the like fractions mean simply that they have the same denominators. It does not do anything with the value of the fractions, just merely that they have the same number in the denominator. We call them like fractions. When we add like fractions, it's very simple. What we need to do is to add the numerators, the top parts. So for this question number A, we're going to add 24 plus 11, the numerators, and that will give you 35. We are not going to add 150 and 150 to give us 300. We have to keep the denominator the same. When you add a fraction, it's not enough only to just add. You have to simplify your answer if possible. If you go back to our webinar again for last week, we did go over how to simplify a fraction. And just to remind you, simplifying a fraction means that we eliminate any common factors between the top number and the bottom number. I see a 35 ending with a 5 and 150 ending with a 0. From my knowledge about numbers, I know that 5 is a common factor. Eliminate the 5 by dividing over 5 top and bottom, and that will eliminate it and reduce the fraction to the simplest form. 35 divided by 5 is 7. 150 divided by 5 is 30. Let's look at 7 and 30. Anything common? And the answer is no. There's no common factors between 7 and 30, so this is your answer. 7 over 30 is the sum of these two fractions. Number B, it's a mixed number plus a mixed number. What should we do in this case? Again, look at the fraction part. Like fractions, that's the easy kind of addition. So in this case, just add the whole numbers, add the numerators, and keep the denominators the same. 1 and 3 is 4. 1 and 2 is 3. And then keep the 4 in the denominator. 3 and 4, there's nothing common, so this is the final answer. It is in simplest form already. Let's look at number C. Number C, I have a star beside it because there is something different about simplifying the fraction when we add the fraction. So any question in this webinar having those stars, it means that it is a special question. You may see it in the exam, you may see it in the practice, and this is how we do this kind of question. And again, mixed number plus a mixed number both have a 17 and the denominator like fractions, then this is the easy kind of the problems. 3 and 5 will give you 8. 4 and 15 will give you 19 on the top, And of course, you have to keep the 17 on the bottom. Now, this is not in simplest form. There is no common factors between 19 and 17, but the fraction part of this answer is an improper fraction. And that makes our answer not in simplest form. To make it in simplest form, to put the answer in simplest form, we have to simplify the improper fraction to the mixed number form. And we do that by writing the fraction, which is an improper fraction, into two parts. The first would be 17 over 17. Remember, an improper fraction values more than one or more. So the 17 over 17 is a 1. Anything over itself is a 1 whole. Now, what is the leftovers from the 19 if we take away 17? 2. Then the other part that represents this original fraction is 2 over 17. Now I'm going to take the 17 over 17. I'm going to think about it as a 1, number 1. And I have a whole number, 8. Add them together, 8 and 1 will give you 9. So the answer would be 9 and 2 over 17. And this is the simplest form of the sum. Well, this answer is correct, but is not in simplest form. This answer is correct and in simplest form. Number D, 13 and 3 over 4 plus 5 over 4. Again, mixed number, same denominators. I always have to mention to myself, what do I have in my problem? That is a reminder. So I hope that you do the same thing. You have to speak loud, but remember, remind yourself, what do you have on the problem? What kind of a problem you have? So that way you know which directions you're going to go. Now, 13 plus nothing is 13. There's no whole number there, so it's going to be 13. And 3 and 5 is 8. And 4 will stay the same. Look at the fraction. 8 over 4. It's an improper fraction, but 8 over 4 we know is what? 8 divided by 4 is what? Is a whole number 2. So this is actually a whole number 2. And I have a whole number 13. Add 13 and 2 will give you 15. And yes, the answer is a whole number, even though we started out by adding a mixed number and a fraction. So it is possible that your sum of two different fractions would be a whole number. If you do everything correct, and this is your answer, then it's your answer. Any questions on this slide? Anything that did not make sense? For students who just joined the webinar, you're able to type your answers, your questions on the questions box, and I'll be able to answer them as I get them. And please keep them relevant to the webinar. These questions that I have throughout the webinars are self-checks. The self-checks are just questions for you to try the concept that we have just gone through together. These questions are not graded. These questions are given to you to self-assess yourself and see where you are from understanding that topic. So what's going to happen with these questions whenever we get them? You have the question on the screen now. You're going to take a moment and think about the question. You can write it down on paper. You can apply the rules that we have gone through together. You can choose your answer, and then I'll change my screen to give you the same question and a chance to enter your answer. So again, the question on the screen is two mixed numbers added. They have the same denominator. They are like mixed numbers. So what do we do? What do you think? Write the question on a paper. Think about it, do the same process that we have been doing so far, and see which answer is the sum, A, B, C, or D. Two and 1 over 8 plus 1 and 3 over 8 equals to what? I'm going to change my screen. you'll be able again to see the same question, but this time you have a chance to enter your answers. What do you think? What is the correct sum of these two mixed numbers? Remember that whenever you add, you need to also simplify your answer. In the exam, the answer displayed in the answer choices in simplest form. So even if an answer does not make sense, try to add, simplify, and then pick your answer. I'm just going to wait for everyone to vote and enter their answers, and then we can do the question together. A few more seconds, and then we can proceed with the question and then look at the next slide, which is another self-check on the same topic. What do you think? What is the sum of the two mixed numbers that you see on the screen? And again, if you've just joined us, those questions are not graded. They are not part of your grade. They are given to you to assess yourself. Even if you find out later that you have answered the question incorrect, do not get discouraged. We're here to practice together. You can ask your questions. I'll try my best to answer your questions. We're learning. So we're not judging each other's. So try to do the question and see why you have it wrong if you have it wrong, and good job if you have it right. Okay, let's then move on to the question and see how can we add. Again, two mixed numbers with the same denominators. They are like mixed numbers, so simply add 2 and 1 is 3, 1 and 3 is 4 on the top, and then 8 will remain on the denominator. Now, 3 and 4 over 8 is what? 4 and 8. There is a common factor between 4 and 8, so this is not my simplest answer. I have to divide over what? What is the common factor between 4 and 8? Use your knowledge of the multiplication table. Divide over 4 and divide over 4. Do not divide the 3 over 4. Just a fraction. We're trying to reduce the fraction. Equals to 3 and 1 over 2. So the answer is 3.5, which is B. This is another question on the same topic. 2 and 4 over 5 plus 1 and 2 over 5. Again, look at the question. What kind of question is that? This is like fractions or like mixed numbers. So what steps do we have to take to add the two mixed numbers? Again, write down the question. Try to be neat when you write your numbers so everything is clear which number belongs to which fraction. And do step by step and find out the simplified sum of this or these fractions. Two and 4 over 5 plus 1 and 2 over 5. I'll give you the question again in a different screen, and please participate in those questions. And here you go. Remember, if you have an improper fraction part of your answer, you have to do something to make it in simplest form. You need to think about the improper fraction in terms of what and what. Write down everything that you think about on paper and see if it does make sense, and then go to the next step to write your final answer. few more seconds, and then we'll do the question together and see which answer is the simplest form sum for these two mixed numbers. Okay, let's do the question together. Again, the question has two mixed numbers with the same denominator. I'm going to repeat myself a lot in this webinar. It is because the more you hear it, the more you see it, the more you do it then. After we end the webinar, you're going to do the same thing by your own. So the same denominators, then we're going to do add the whole numbers. 1 and 2 is 3. 4 and 2 is 6, and then keep the 5. This is not in simplest form. 6 over 5 is an improper fraction. An improper fraction means that the answer is not in simplest form. Break down the improper fraction to two other fractions. 5 over 5 would make a whole number 1. And then the leftover 6 minus 5 is a 1. 1 over 5 is the leftover. 5 over 5 is a whole 1. 1 and 3 will give you the 4. And then the leftover would be the fraction part of the answer. So the answer is 4 and 1/5. So A is the correct answer. If you have any questions, the raise your hand button is not available in our webinars. You can type in your question in the questions box. Next, let's look at subtraction. We're gonna keep it like fractions as well. So these are the easiest end of the topic that we have with addition and subtraction. So we're still gonna subtract like fractions, and we're gonna do the same thing. Gonna keep the denominators the same. We're gonna subtract the numerator. So number A, 21 over 45 minus 17 over 45, common denominators. So simply subtract 21 minus 17 will give you 4, divided by 45. 4 and 45, nothing common between 4 and 45. So the final answer is 4 over 45. Number B, 3 and 5 over 6 minus 2 and 4 over 6. Again, same denominators. We're going to do the same thing as we did with the mixed numbers when we added them, but this time we're going to subtract. 3 minus 2, we're going to subtract the whole numbers, is 1. 5 minus 4 is also 1, and then we keep the 6. 1 and 6, nothing common, so the answer is 1 and 1/6. The last one has a star, and that star means that this question is a special kind of question. Some subtraction problems, you may have to use the method of borrowing. And we know that we have to borrow when we have the same denominators the same, we have a mixed number in the minuend, and also we notice that the numerator on the first one is less than the numerator on the second one. 1 minus 4, we cannot do that. So we have to borrow. We have to borrow a 1 whole from the 6, give it to that fraction part, and then try again to subtract. So we would overcome the fact that the first number is smaller than the second number. The way we're going to borrow is we have to take a 1 out of the 6. The 6 will go down to a 5. And then the fraction part for that first mixed number will consist of two fractions. The one I borrowed, I can rewrite it as 10 over 10, which is a 1. And then plus the original fraction, 1 over 10. These two fractions is the fraction part of the mixed number, minus, we still have to subtract minus 3 and 4 over 10. Let's combine the two fractions here and rewrite our problem as 5 and then 10 plus 1. It's an addition, same denominator, follow the rules for addition. 10 plus 1 is 11 over 10. And we still have to subtract 3 and 4 over 10. Now look at the problem. 11 minus 4, yes, we can do it. We have common denominators, so all we have to do is to apply the same rules we did with number B. 11 minus 4 will give you 7. 5 minus 3, of course, is going to give you the 11 minus 3, I'm sorry, it's going to give you the 2. And then over 10. So the answer is 2 and 7 over 10. Nothing common between 7 and 10. It's a proper fraction. Then that is it with the subtraction. Any questions? Anything that was not clear on the borrowing method? Okay, Marlene is asking a good question. How did you come with a 10 over 10? Should it be 11 after borrowing from 6? Well, Marlene, we did borrow one whole from the 6. I can represent the one whole as 100 over 100, 200 over 200, 2 over 2, 3 over 3, 5 over 5. Why did I specifically chose 10? Because look at the denominators. 10. Why would I make my life harder and make it 5 over 5? And then I know I have to add that to 1 over 10, different denominators, find a common denominator, and then add. I can just pick it to be 10 over 10. So it is consistent with my denominator. So when I add 10 over 10 to 1 over 10, that is easy for me. That's why I specifically did it as 10 over 10. So the 10 over 10 is the whole 1 that I borrowed from the 6. I added that to the fraction part already there in the problem, and that together made the 11 over 10 fraction part of the first mixed number. Did I answer your question, Marlene? Okay, let's move on to a self-check question. 10 and 3 over 5 minus 2 and 4 over 5. Look at the numerators. Do you see a problem? Do we have to borrow, or it's just a simple subtraction problem? What do you think? Again, write down the problem on a piece of paper. When you rewrite the problem, that's what I find. I understand more about the problem. When I write the problem, I realize I have common denominators. When I write the problem, I realize I have the first numerator smaller than the second numerator, so that would make me think about doing what? Should I borrow or no? Okay, so think about the borrowing. If you said, yes, I'm going to borrow, you're going to borrow 1 from the 10. The 10 becomes what? And to make it easy for you, you're going to represent the 10, the 1 that you borrowed, in terms of what over what, since you have a 5 in both denominators. What do you think? Okay, I'm going to display the question again, and you're able to pick your answer. Here you go. Marlene and Camden, yes, your answers are correct. So move on to the next steps and see what would be the final answer for this subtraction problem. I'm going to allow more seconds or more time, just a few time, because we have a lot to cover today in this webinar for everyone to participate and see if they got that topic right. Borrowing is one of the challenging topics in adding and subtracting. So I don't want to say you will have to see a problem in the exam, but I mean, I think you will encounter maybe one or two of these in the exam. So make sure that you do that correctly. Okay, let's do the question together. So again, I'm going to decide to borrow. Just because 3 is smaller than 4, 3 minus 4, I cannot do anything about that, so borrow. So when we borrow, we will have to make the 10 9. That 1 borrowed from the 10, I'm going to represent in terms of 5 over 5, just because I have the denominators as 5, so just to make my life easy, plus the original fraction, 3 over 5. And that is all the fraction part of the first mixed number. I still have to subtract minus 2, 4 over 5. Combine the two fractions for the 9 and 3 plus 3, 5 plus 3 will give you 8 on the top, 5 will stay. These are the addition rules. And then minus 2 and 4 over 5. I did overcome the problem I had. So then now the first numerator is greater than the second. Now I'm able to do the subtraction. 9 minus 2 will give you 7. 8 minus 4 will give you 4, and 5 will stay because it's the common denominator. 4 and 5, nothing common. It's a proper fraction, so that is it for the answer. So answer number C is the correct answer. If you have any questions, again, the raise your hand feature is not enabled just for our privacy policies. So if you have a question, you can type your question and it pops out on my screen and I'm able to read them and answer them if they are relevant to the webinar. Let's go ahead and do another question with subtraction. 5 and 7 over 10 minus 2 and 3 over 10. Borrow or no borrow? What do you think? What do you think? From there, if you decided to borrow, go ahead. No borrow, go ahead and do the steps. Look at the numerators. 7 minus 3, doable or no? What do you think? Is it a simple subtraction problem or you have to borrow? Gonna leave you with the question and then change my screen later. Okay, Camden, you're right. Your answer is right. I'm going to reveal it at the end so everyone have a chance to think about the problem, but you're right. Okay, let's change my screen and then please enter your answers. A few more seconds and then we'll go over the question together and see if it's a borrow or no borrow. I mean, you can borrow always, but if you do not have to borrow, why would you make your life harder? You can just go the easy way. Let's do the question together and see what the answer would be for this subtraction problem. Again, common denominators, that's good. I have 7 minus 3. yes, we can do that. So this is a simple subtraction. No borrowing is needed. So I just can go with the easy way. No borrowing. So 5 minus 2 is 3. 7 minus 3 will give you the 4. And then 10 will stay. 4 and 10, two even numbers. The common factor between 4 and 10 would have to be what? 2. So divide over 2, top and bottom. To simplify the fraction part, do not divide 3 over 2. So it'll be 3 and then 2 over 5. 3 and 2/5 is the difference between these two mixed numbers. So the answer is B. Any questions on this problem? Okay, let's go ahead and do a different topic. Now we're getting harder on the topics. Unlike fractions. How can we add two unlike fractions? So when we add two unlike fractions, again, unlike fractions are the fractions has no common denominators. The numbers on the bottom are different, 3 and 5. So these two fractions are unlike. We cannot do 1 plus 3 and then 3 plus 5 and that would be the answer. It's not that easy. We have to get back to the step where we had been adding like fractions. We have to change one or two fractions so the problem has all fractions with the same denominator. To do that, I need to look at the numbers I have on the denominator, 3 and 5. I know 5 is not a multiple of 3. 3 times what is 5? Nothing. So I need to find that number that we call the least common denominator, or the least common multiple to be more accurate. The least common multiple, you can get that manually. I'm going to show you the manual way, and then I'm going to show you later the way that you just get by doing more practice about your knowledge about numbers. You'll be able to just find that common denominator without doing the manual way. But I'm going to show you the manual way. If you have to use it as a last resort, you can do that. To find the least common multiple, I'm going to list all the multiples of both denominators, 3 and 5. I'm going to get the multiples by multiplying. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4, 12. 3 times 5, 15. I'm not going to list all of them because they will never end, but I'm going to just, list some of them and stop. The 5 the same way. 5 times 1 is 5, times 2 is 10, times 3 is 15, 20, 25, and so on. Compare the two lists. Which number that you see in both lists? What do you think? 15. 15 is the least common multiple. This is going to be our new denominator. Our new denominator is 15. Now we have to think about it so carefully because to get 3 to 15, we have to multiply 3 times what? 3 times what will give you the 15? I'm talking about the first fraction. I'm trying to change the first fraction to an equal fraction with a 15 in the denominator. 3 times what is 15? 3 times 5. Multiply times 5. Remember the very basic rule of fractions. If you multiply a number on the bottom, you have to do the same thing on the top. So you keep the same fraction balanced or having the same core value times 5. The first fraction then can be rewritten as 1 times 5 is a 5. 3 times 5 is 15. I did my goal on the first fraction. Now it has a 15 on the denominator without messing up the value of the fraction plus. 5 times what will give you 15 times 3? So do the same thing on the top, times 3. 3 times 3 is a 9. 5 times 3 is, again, 15. At this point, if you look at the two equal fractions, they have the same denominators. I did change the unlike fractions to like fractions. They have the same value. So we're going to go ahead and apply our addition rules. Add the numerators and keep the denominator. 5 plus 9 is 14 divided by 15. Since 14 and 15, no common factors, it's proper fraction, then this is the answer. This is the sum of the two fractions that we started out with. Any questions? Anything that was not clear? Make sure that you know how to find the common denominator, because every time you're adding or subtracting unlike fractions, you will have to go through that process. Okay, let's do the second one. 7 over 12 plus 23 over 24. These are two unlike fractions. I'm not going to go ahead and add. I have to do something else to prepare my problem properly before I do operate the addition. So I'm going to look at the numbers. I'm going to decide in my mind what I'm going to do. Well, I noticed something special about my numbers. It's a gift given to me. 12 and 24. Isn't that 24 a multiple of 12? In that case, I have to only change one fraction, not both like the first problem. So if I multiply, 12 times 2 will give me the same denominator already there in the second fraction. So do the same. 2 and 2. And rewrite the first fraction. 7 times 2 will give you 14. On the bottom, 24. And look what the second fraction has, 24 in the denominator. So I'm ready now to add. The same rules, 14 plus 23 will give you 37 on the top, and 24 will stay. Think about, is it in simplest form? And the answer is no. This is an improper fraction. I need to change that to a mixed number form. So think about this fraction in terms of two other fractions. 24 over 24, that's a whole number 1. And then the leftover, you can figure it out by 27 minus 24 will give you 13 on the top and over 24. So your answer will be 1 and 13 over 24. On the first webinar, we did think about changing the improper fractions to a mixed number another way. We said, how many times 24 goes into 37? Once. And then we figured out the leftovers, 13, and that becomes the new numerator. If you want to have a look at the first webinar, again, it's available on YouTube. Any questions about how to find the common denominators when we add unlike fractions? Okay, let's move on to a self-check problem on this topic. 11 over 35 plus 10 divided by 7. Unlike fractions, we cannot add right away. I have 7 and 35. Does it click anything in your mind? 35 and 7. 35 and 7. Can you change one fraction only and then add, or you have to change both? What do you think? Write down the problem, look at the numbers on the bottom, and decide which fraction will be changed, or maybe both. What do you think? Roger, I see your question about one of the self-check question we did together. So I will go back to it. If I have time left and everyone is okay staying over time, I can go back and do the question again. What do you think? What is the sum of the two unlike fractions that you see on the screen? I'm going to change my screen now and give you the question. You still have time to think about how to do the addition and what is the common denominator. For students who are attending this session today, if you have to leave in the middle, you will get the recording. If you have registered with your correct email address after the session ends today, after like about 5 hours, you will get a recording sent to your email address that you have provided upon registration. So if you have to leave, feel free. You will get the recording. And if you have any questions, there is an email address there provided. If you have questions, you can send them to that email address. Okay, let's do the question together. So again, we have unlike fractions. I'm going to use the feature I have on my numbers. 35 is a multiple of 7. That tells me I have only to change one fraction, not both. So this is half of the work only to be done. So multiply 7 times what to get your 35? 7 times 5. This is your knowledge of the multiplication table. Times 5 and times 5. Rewrite the problem, the first fraction as is. The second fraction, 10 times 5 is 50. And then 7 times 5 is 35. This is what we need. This is our goal. The denominators are the same. Add the numerators. 11 and 50 would give you 61 over 35. Again, not a proper fraction. It's an improper fraction. This is not the simplest form. Either you break down the fraction to two different fractions, or you can think how many times 35 goes into 61 and then figure out the difference. Both ways will get you to the right mixed number. So I can think of this fraction as 35 over 35. That's a 1, whole number 1. And then the leftover would be a 26 over 35. So the answer is 1 and 26 over 35. There's nothing common between 26 and 35. Then the answer would be, in this case, number D, 1 and 26 over 35. Any questions on this problem? Anything that was not clear? Okay, let's move on to the next self-check problem on the same topic. 2 over 9 plus 5 over 6. 2 over 9 plus 5 over 6, two unlike fractions. We have to add them. Are we going to change one or two fractions in this case? Is 9 a multiple of 6? 6 times what will give you 9? If you answer that question correctly, you will know then how to get to the next step. What would be the common denominator that is a multiple of 6 and also a multiple of 9? And if you're not sure, you can do the manual way. You can list the multiples of 9, list the multiples of 6. The first number that you see common between the two lists, that would be the common denominator that you're going to use in this addition problem. going to give you the question again on the different screen, and you can share your answers. 2 over 9 plus 5 over 6. What is the common denominator, and what is the sum of these fractions? A few more seconds for everyone to get the chance to share their answers. What is the common denominator if you have a 9 and a 6 in the fractions that you have to add? What do you think? Camden, you're right. So what is the common denominator? What do you think? Okay, let's do the question together so everyone get to see how to do the addition problem. Again, I'm gonna have to change both fractions because 9 is not a multiple of 6 and obviously 6 is not a multiple of 9. So I'm gonna think about the number. The number you're gonna figure it out when you do it manually, or if you use your knowledge of the multiplication table, you know that 18 would be our new denominators. So 9 times what will give you 18? 9 times 2. And 6 times what will give you 18? 6 times 3. Let's do that and change our both fractions and see what's going to happen. 9 times 2 and 2 times 2. 6 times 3 and 5 times 3. Remember, most students who do get answers incorrect in this type of question, they forget to multiply the same number on the top as well, and they end up with the incorrect answer. So let's rewrite the question. 2 times 2 is 4. 9 times 2 is 18. The common denominator that we wanted to see in this problem, plus 5 times 3 is 15. And then 6 times 3 is 18. Now we have like fractions. We did not change the problem. We only changed how the problem looks like, but it is the same thing. Now add 4 and 15 will give you 19 over 18. This is not in simplest form because this is an improper fraction. This is 1 and 1 over 18. So the answer is C. Any questions on that problem? Okay, remember when you work with fractions, you need to, again, rewrite the problem neatly. You need to decide which way you're going to go. Everything you think about, or any step that you think is the right step, you have to answer the question why. Why do I have to pick 18 as a common denominator? Why I have to change my answer to a 1 and 1 over 18? If you are not able to give a reasoning for your upcoming step, it means that you either need to review the unit, or maybe the step you are about to do is not the right step. It has to have a reasoning why. Let's look at the next topic. Subtracting unlike fractions. Okay, with subtraction, you know that we will have to borrow eventually. But let's start with the easiest type of questions when you have to subtract unlike fractions. Again, it's the same process when you find the common denominator. 7 and 28, what do you think? What is the common denominator? 28, is it a multiple of 7 or no? Yes, it is a multiple of 7. Then we're going to change only one fraction. 7 times what will give you 28? 4. 7 times 4 and 2 times 4. Rewrite the problem. First fraction as is, 17 over 28, minus 2 times 4 is 8. 7 times 4 is 28. Now we have like fractions. We're able to apply the simple rules of addition, add the numerator, and then simplify the answer if possible. 17 minus 8 will give you 9. Keep the denominator the same. 9 over 28, that is it. There's nothing to simplify, so this is the difference. Again, number B, 7 over 12 minus 3 over 10. Are we going to change both fractions or one fraction? Is 12 a multiple of 10? And the answer is no. If the answer is no, that means that we have to change both fractions. What is the common denominator? What is the least common multiple between 12 and 10? If you're not sure, do it the manual way. Okay, I just gave you a few seconds to think about the number before I go ahead and do the question. 12 and 10. If you list the multiples of 12 and list the multiples of 10, you will realize that 60 is the least common multiple between the two numbers. So 12 times what will give you 60? 12 times 5. Do the same thing on the top. 10 times what will give you to the same common denominator, to the 60? 10 times 6 and 3 times 6. Let's rewrite the problem. The first fraction would be 7 times 5 will give you 35 on the top and 60 on the bottom. Minus 3 times 6 on the top will be 18. And again, 60 on the bottom. This is what we need. Common denominators in able to subtract the numerators. 35 minus 18 will give you 17 over 60. Nothing common. This is your final and simplest form of the answer. Any questions? Let's move on to a self-check problem. Again, 3 over 4 minus 2 over 5. Do you think, are we going to change both fractions or one fraction? Is 5 a multiple of 4? Based on your answer to this little question, you will know if you have to change one or two fractions. Write down the problem again. If you have to do a manual way to find the common denominator, take the time to do that, and then decide on the common denominator. Okay, Roger, I'm happy that you did figure out the previous question that you had. You also will receive the recording, so you can stop the video whenever you want, write down the problem, and follow step by step if you have any questions on any of the problems that we went through. What is the common denominator to use if you have a denominator of 4, a denominator of 5? What do you think? I'm going to change my screen to give you the chance to share your answer. Here you go. Okay, let's do the question together. Again, unlike fractions, whether we add or subtract, we have to find a common denominator. From our knowledge of the multiplication table, we know that 20 would be the common denominator. Times 5 will give us the 20, times 5 will give us the 20 on the first fraction. Times 4 and times 4. Rewrite the problem. 3 times 5 is a 15, divided by 20 minus 2 times 4 on the top will give you 8, divided by 20. And then we just subtract the numerators. 15 minus 8 will give you 7 over 20, and the answer would be C. That's it. Okay, let's then look at a different topic. What if we want to add unlike mixed numbers? Well, the process is going to be the same. We're not going to be able to add right away, obviously, but we have to find the common denominator for the fraction parts of those two mixed numbers. Again, 3 and 7. 7 is not a multiple of 3. Then what is the common denominator, do you think? 21 is the common denominator. Change the first fraction and the second fraction, times 7 and times 7. Times 3 to get us 21, and times 3. Rewrite the problem. Notice that I did not multiply the 1 times 7 or the 3 times 3. That is another common mistake that I see in students' work. We did not change the whole number parts, only the fraction parts. So rewrite the problem. 1 and 7 over 21 plus 3 and 15 over 21. We're adding, so add the tops. 7 and 15 will give you 22. 1 and 3 will give you the 4, and then 21 will stay the same. Again, 22 over 21. This is an improper fraction. Think about it in terms of two fractions. 21 over 21. The leftover between 21 and 2 is 1 over 21. This is a whole number 1. I have a whole number 4. Add, so the answer would be 5 and 1 over 21, and this is the simplest answer. Again, number B, the same way. We have a fraction plus a mixed number. They are unlike. So think about the common denominator. 30 is a multiple of 6. So that will make me only change the second fraction, 6 times 5, and 6 and 5 times 5, because 6 times 5 will give me the 30, which is then will be our common denominator. 19 over 30 as is, plus 7, and 25 over 30. Now I can just add like before. Nothing plus 7 is 7. 30 will stay in the denominator, and then add 19 plus 25 will give you 44. Now 44 over 30, that's not in simplest form. Think about it like this. 30 over 30. The leftover would be 14 over 30. That's a 1. Plus 7 will give you the 8. And then the fraction part of the answer would be 14 over 30. I'm not done yet. 14 over 30. These two numbers are even numbers. There is a common factor to eliminate. Divide over 2 and divide over 2. We're not going to divide the 8 over 2. We're only simplifying the fractions. So equals to 8 and 7 over 15. And this is your simplest form of the answer. Any questions? Anything that was not clear or did not go along with what you've read already in the lesson? Okay, let's do a self-check question. Again, the same topic. You have two numbers. One is a fraction. The other one is a mixed number. They have different denominators. What should we do? What is the common denominator? Is one of the denominator a multiple of the other denominator or no? I'm going to leave you with that problem and then come back to change my screen. Okay, let's put the question again on the screen here, so everyone is able to input their answers. What do you think? What is the sum of 17 over 100 and 5 and 14 over 25. Okay, I see that everyone who had shared their answer did pick the right answer. And that tells me that you did get the concept. Okay, let's do the question together. So again, from our knowledge, 100 is a multiple of 25. 25 times 4, and then we have to multiply the top times 4. 17 over 100 plus 5. And then 14 times 4 will give you 56 divided by 100. And then you just add 5 plus nothing will give you the 5. 17 plus 56 will give you 73 over 100. And this is the simplest form of that fraction. So the answer is 5 and 73 over 100. Good job. Let's go back to the topic. Now we're going to do the same thing. The only difference is that we're going to subtract now. So these kind of problems are subtractions with unlike fractions. And we know by now that with mixed numbers being the first number appearing in our problem, we may have to borrow. So we have to keep an eye on what kind of problems we have and then decide whether we borrow or no. The first question, 5 and 9 over 14 minus 1 and 1 over 2. 14 is a multiple of 2 because I'm able to multiply 2 times 7 to get the 14 and do the same thing on the top. Rewrite the problem. 5 and 9 over 14 minus 1 and 7 over 14. Now decide. After we've changed our problem to a problem with common denominators, now we decide borrow or no borrow. 9 minus 7, doable. Then it's a no borrow question. So 5 minus 1 is a 4. 14 will stay. 9 minus 7 will give you 2. This is not the simplest form. Divide over 2 and divide over 2. Then 4 and 1 over 7 is the final answer. Questions? Anything that was not clear in that one problem before we go to the borrowing? Okay, now look at the question. 10 and 13 over 20 minus 4 over 5. From looking at this question, we realize we have unlike fractions. Do not attempt to decide if you're going to borrow or no borrow in this step. You have to change the problem to have like fractions first. Because if you look at this problem, 13 minus 4 is doable. And that would make you think that you have a no borrow question, but this is not true. We have to change the problem first and then decide. So we have 20 and 5. So 20 is obviously a multiple of 5. 5 times 4, we have to do the same thing on the top. So the first fraction will stay the same. 10 and 13 over 20 minus 16 over 20. Now we decide, is it a borrow or no borrow question? 13 minus 16, that's not doable. This is a borrow question. Okay, so the same thing that we did previously, we have to borrow 1 from the 10. The 10 will become a 9. That 1 we can rewrite as 20 over 20. And why specifically 20 over 20, not 17 over 17? Because I want to make my life easier. I have 20 in the denominators. Still have to add 13 over 20. This is my original fraction, minus 16 over 20. Combine the two fractions, then it will be 9 and 33 over 20 minus 16 over 20. Now I'm able just to perform the subtraction. 9 minus nothing is 9. I have the 20 still in the denominator. 33 minus 16 will give you 17. Nothing common. It's a proper fraction. Then this is the difference. Questions on this problem? Anything that was confusing or did not make sense? Okay, let's go to a self-check problem. 24 and 7 over 15 minus 2 and 2/3. What is the difference of these two mixed numbers? I have unlike fractions on both. Is one denominator a multiple of the other? Yes or no? And from there, you can go ahead and change the problem, then decide borrow or no borrow. I'm going to leave you with this question and then change my screen later. Okay, here's the question again. You still have time to work on the question. Make sure that you write the problem neatly, just to know that 24 belongs to that fraction and 2 belongs to the 2 over 3. You have a subtraction sign so clear on your paper that you do not add or multiply. It says subtraction. What is the difference between the two unlike mixed numbers? Okay, I have students who have already voted and they had the right answer. Good job. And if you did not have the right answer, it's okay. It means that you can still have a chance to go back to the lesson, maybe watch the webinar again, send your questions to the school, to the instructor to answer your questions before you attend the exam. Few more seconds and then we'll do the question together. I think, in my opinion, this question is the most challenging kind of questions that you will see in this unit. So if you're able to master this topic, everything else will be easy. Okay, let's do the question together. Again, two unlike fractions. One is a multiple of the other. Yes, 15 is a multiple of 3 times 5 and times 5. Change the second fraction only. So 24 and 7 over 15 is the same, minus 2 and 10 over 15. Now 7 minus 10, not doable. It's a borrow question. It's a borrow question. How can I borrow? Borrow 1 from 24. 24 will go down to a 23. That 1 I have borrowed is going to be 15 over 15 plus the original fraction 7 over 15. And then still I have to subtract minus 2 and 10 over 15. Combine the two fractions for the 23. So 23, and then apply the rules for addition. 15 and 7 is 22 on the top, and 15 will stay, minus 2 and 10 over 15. Now subtract, because 22 minus 10 is doable. So 23 minus 2 will give you 21. 22 minus 10 will give you 12 on the top, and 15 will still stay in the denominator. Not the simplest form of the answer, because 12 and 15, there is a common factor between 12 and 15. 3 divide over 3 and divide over 3. Do not divide 21 over 3 equals to 21. and 4 over 5. That's a proper fraction. Nothing common. This is your final answer. The final answer is B, 21 and 4 over 5. Questions on this question, on this problem? Anything that was not clear on the steps that we did together on the screen? Well, Camden, this question is, as I said, the most challenging question in this part of the lesson. So I would advise that you watch the webinar again and do the steps one by one. Do not feel like you have to do everything in one line, for example, or you have to do everything in less than a minute. Really, what it matters is that you get the right answer at the end. So do step by step. It's sometimes confusing. I understand. I did have a problem with fractions when I was in middle school as well. I'm not saying that I was a super math hero since I was born. That is not true. We just take some time to practice and do step by step. Organize your thoughts. Keep a notebook or a paper. Write notes, and you'll get better at it, I'm sure. Okay, let's go to the next question. Really don't have to work out the question. Just tell it's a no borrow or a borrow question. What do you think? 3 and 2 over 5 minus 2 and 3 over 10. Is it a borrow or no borrow? When do we decide? Do we decide looking at the original problem when it has different denominators? Or we have to do a step before we decide? What do you think? Okay, here's the question. And what do you think? Is it a borrow or no borrow? Remember that you have to change both fractions to equal fractions with the same denominator and then take a decision, borrow or no borrow. I mean, as I said, you can borrow all the time, by the way, but it will make your life harder. So if you can figure out when to borrow and when not to borrow, it will become more easier. Okay? Well, 3 and 2 are 5, and then I have 2 and 3 over 10. 10 is a multiple of 5. Change the problem first. So I'm going to do times 2 and times 2. 3 and 4 over 10 minus 2 and 3 over 10. Look at the numerators. 4 minus 3, doable? Yes. So there's no need to borrow. We've gone over the hour. If you want to stay, I would like to see everyone stays. But if you have to go, I also understand that you may not be able to continue the session with me today. Again, you will receive a recording. So even if you have to leave, you will not miss anything. You still have the chance to watch the whole webinar and also ask your questions, sending them to the email address included in the follow-up email. The last topic I wanna cover today is when you add fractions or mixed numbers to whole numbers, or when you do the subtraction on the same kind of questions. 15, a whole number, plus 17 over 26. Addition is a little bit simpler than subtraction. In this kind of problem, number A, just add. 15 plus nothing is 15. 17 over 26 plus nothing. There's no fraction part here, so it's just 17 over 26. Nothing to simplify. This is your sum. That's it. Number B, it's addition. Same way. 3 minus 8 will give you 11. 5 over 7 plus nothing will just give you itself 5 over 7, and this is your answer. Subtraction is the one that you need to do more steps to do. To subtract a fraction or a mixed number from a whole number, you have to change the whole number to a fraction. And we know by now how to do that. So 3 is 2 and 6 over 6. Think about it. 2 plus 1, 6 over 6 is a 1, plus 2 will give you back the 3. So 3 can be represented as 2 and 6 over 6 minus 1 over 6. We have the same denominator automatically because you choose to do 6 over 6, not 7 over 7, for example. So you're going to do the subtraction. 2 minus nothing is 2. 6 minus 1 is 5, and the 6 will stay, nothing to simplify further, and that's it. The same thing, number D, 6 minus a mixed number, change the 6 to a 5, and 4 over 4 minus 1 and 1 over 4. Again, I have common denominators. 5 minus 1 is a 4. 4 minus 1 is doable, then it's a 3, and then the 4 will stay, and this is your final answer. That's it. Self-check question. This is the last question, I promise. Again, 5, a whole number minus a mixed number, 3 and 7 over 12. How can we do that? It's a subtraction, so we have to do more steps than if it were an addition problem. What do you think? How can you do that? Write down the problem, do the same steps, and then decide on your answer. I'm going to change the screen. It will give you the same question. You still have time to think about the problem and enter your answer. Okay, let's do the question together. Simply 5 can be displayed as 4 and 12 over 12 minus 3 and 7 over 12. 12 minus 7, doable. Then it's a simple subtraction problem. 4 minus 3 is a 1. 12 minus 7 will give you a 5, and then over 12, and this is your answer. It's already in simplest form. B is the final answer. That's it. Okay, so today we did go through all kind of questions expected for addition and subtraction, whether with like or unlike fractions, whether with whole numbers or mixed numbers, and so on. So go ahead and rewatch that video if you'd like, this webinar if you'd like, or you can go back to the lesson and then try to match what we've learned today with whatever is said in the lesson. And then if you need, you can then watch the webinar again. Before I leave you today, I just want to make sure that I give you some exam preparation exam preparation tips. You have to read the lesson. You need to practice the practice questions given in the lesson. They are there for a purpose because they prepare you well in the exam. The answer key for those practice questions within your lesson are provided. So when you work a question and you find an answer, compare your answer with the given answer key. If they match, then good. If most of your answers are incorrect, they are not the same as the answer key, that means do not proceed to the exam yet. You still have to reach out for help, reread the unit, watch the webinar, or ask for help somehow, but do not proceed to the exam if you're not confident enough that you will score good on that exam. Also, I want to give you where to go for help. You can call, you know that, 9 to 6 Eastern time. On weekdays, we're closed on the weekends and holidays, but we're always here from 9 to 6 Eastern time. You can schedule an appointment with an instructor or teacher assistant using this link. So the link will allow you to specify the date and the time, and we call you back on that day and time. And we just ask you to leave when you schedule an appointment what kind of topic that you need in that course. So that would be another way to reach out for help. You can text message your brief question. If you have a question on your lesson, you want to type learn in your text message. Also, you can email or chat through your portal. These are two different kinds of portal. They function the same way. We just change things where things show up on the accounts. So both have the same features, chat and email, and also the same thing with the other accounts, chats, or email through your or the help and support tabs or the help center tabs. You can go ahead and follow those steps, and you're able to chat and email. Chats are always available within the operation times from 9 to 6 Eastern time. If you chat with us over the weekend, no one will respond. I want to take the time to thank every one of you. You did participate in this webinar. I'm so glad that you did show up today. Even if you did not, you still have the recording sent to you, so you still have a chance to watch and ask questions. I will ask if you can take a short survey, 3 questions, just to give me a feedback on how I did throughout the webinar, or anything I have to improve or you think I should improve on the upcoming sessions. Next week, we have the last webinar in this series about division and multiplication. If you did not register, make sure that you register for this webinar so you're able to attend or get the recording. Thank you for everyone, and I wish you all the best in the exam.